Hey everybody, Rocket Stove 2021. So, look, jet flame, easy. This is not what a top-lit updraft stove does, which is trying to make jets of air across the top of the fire into the fire, and that's called secondary air. And so that's trying to make the fire clean. And we thought, well, all right, but in a rocket, that air can be really cold. It just cools everything down. So why don't we blow the air up from the bottom into the charcoal? And so, and also it was cheap. Like in this, you know, you just have a bit of cast iron, and so this thing is like $11. And so we thought, well, okay, this can go into many stoves. But guess what? We made a huge mistake. We thought, because we're silly little engineers here in Oregon, hey, let's put it in through the front. Won't that be cool? But our friend Jean-Marie in Rwanda said, you guys are idiots. Hey, when people use it, they burn up the cord. Dummies. Hey, put it in through the side. So this makes me extremely happy that Jean-Marie helped us so much from Rwanda. Thank you. And so now we have the same thing going in from the side. And I just, today we tested it, same, no problem. And so isn't that great? I mean, I think engineers in the lab, we can figure out heat transfer, combustion efficiency, but we cannot be too smart because people in the field are actually cooking. Why are we using beautiful kiln-dried Doug fir from the local yurt factory to test whether the jet flame in the side was the same as the jet flame in the front? Because when we use real wood, this wood doesn't smoke very much. This one smokes like crazy. And so 1 inch of bad bark can just make so much smoke that we can't compare the results. And so we do different things. When we're trying to figure out, okay, what's it going to look like in the field, you try to get as close to their wood as we can. But thank you, Yurt Factory. When we're just trying to say, hey, let's get statistical confidence, then we have to reduce the variables, and we end up using good wood that you know doesn't have any bark. All right, so now we're cramming all this stuff in here, everybody. But I wanted to show you. Remember, there's a jet flame in there, and so one of the things about a jet flame is that you can adjust the speed of the jets coming up into the fire, and that really helps with how fast food cooks and the firepower. So now we're at 2 volts, and now I'm going up to 3 volts. All right. Now I'm going up to 4 volts. Oh, you can hear that fan starting to buzz. Now I'm going up to 5 volts. Look at that thing, it's starting to be more active. And now I'm going up to 6 volts. So the amount of power in the fire can be adjusted by how much air. And now we're going up to 7, which is about the maximum that we want to go, so we don't want to use up too much power. So, the thing about the rocket is how far you stick the sticks in has a lot to do with the firepower. So you can adjust by metering the fuel how much wood is burned and how clean it is and how much wood you're going to use to cook. But in the jet flame, you can also adjust the primary air, and that also has a substantial effect on firepower. Pretty groovy, huh?